So we're going to do an example problem here where we're going to show our work. Now the work here is not going to be perfect. We're going to do it together. And as I've mentioned before, usually you're going to do some type of rough draft and then you'll clean it up later. This is going to be a moderate rough draft. It's not going to be so sloppy as it's one of those things that you sketch off on some cardboard box, pizza box, napkin, just getting stuff on paper. We're going to try to organize it pretty well, but afterwards we could go back, we could clean it up and make it a little bit nicer. So the problem is the rainfall measured at the airport in Forks, Washington for the entire month of January 2020 was 30.78 inches. The city is 4.11 square miles. How many gallons of water fell on the city of Forks for the month? So the very first thing that we do for our solve method is we draw a picture. We'd have some type of sketch. And so I'm going to draw a little box, and I'm going to call this box Forks. That represents the city. Now, it doesn't have to be a beautiful picture. I'm not the great artist. But it hopefully is going to be meaningful. So I have this city of Forks. It's an area. I kind of drew this square to show that it's an area. And what happens is rain falls on it. And as rain falls on it, it's going to flood the city of Forks. At least that's what's going to happen in my picture. And by the end of the month, Forks has become covered with water. Now I want to make sure that this is somewhat meaningful. I have a decent picture here, but I want to make sure that I label a few things. And so I'm going to say that this here is the area of Forks. And I'm going to say that this is the height of the rain. Now it's sloppy. Again, if I were to do this more cleanly later, we would go ahead, I'd get some paper out, I'd write it a little bit more neatly. Either that or I'd practice writing on this a little bit better so I could do it more neatly. But this gets an idea of what's happening. I have an area, I have water fill it up, I now have the picture of what's happening. I'm going to go ahead and I'm going to make a little bit of a checklist. I want to first find the area find the volume by using the area and height. So that's the first thing I want to do. Second thing I want to do is I want to convert my volume to gallons. And that really gets me kind of started on what I want to do here. Now we always want to make a few assumptions, and so I'm going to make some assumptions here. I can make an assumption that this rainfall was measured at the airport. I could say that the entire city got the same rainfall. I could also say that it was measured accurately. And these are just some little things. There are probably other things we could do, but it's very important for us when we have this real world problem. It says that the airport measured this. We have to make sure first that it was accurate. We also need to make an assumption that, yes, it was measured at one point, but we're going to assume that it was even over the entire city, or at least that the average was the same over the entire city. I'm going to list my variables here. And this is a simple problem. I don't really have a whole lot of variables. I have the height of my rain, and that equals 30.78 inches. I have the area of Forks, and that equals 4.11 square miles. And I have the volume of water, which I don't know yet. I'm going to list out my equations. Now, I really only have one equation, a specific equation that I need, and that is that volume equals area times height. But I'm going to put a couple more things in here because I already looked ahead and I know that I need a few things. I know that I'm going to need to convert from whatever I have here, and when I multiply my height and my area, it's not going to be in gallons. It's going to be in inches and miles. And so I'm going to have to convert my miles to feet. I'm going to convert my inches to feet, and then I'm going to go from cubic feet to gallons. I already thought this out ahead a little bit. You might have to do a little bit of thinking, looking at a conversion chart and figuring out how to do this. I'm going to go ahead and write these down for now. So 1 mile equals 5,280 feet. I have that 1 foot equals 12 inches. I have that 1 liter equals 0.0353 feet cubed. And I have that 1 liter also equals 0.264 gallons. And again, these can be looked up as well on any conversion chart, or just do a search for them. So the next step is we're going to manipulate. We're going to start putting our numbers in and we're going to start solving for things. And so what I want to do is I want to solve for my total volume. And to do that, I'm going to take the volume of my water and set that equal to the area of Forks times the height of the rain. And so when I plug values in, I'm going to get 4.11 miles squared times 30.78 inches. When I do the math, I'm going to get 126.5058 miles squared inches. So you'll see that I really did nothing here except for I multiplied the things together, and I was very careful about multiplying my units as well. I didn't convert miles to feet. I didn't convert inches to feet. You could have done that already, and then the answer would have been in feet cubed. What I've done so far is I just kept it the way that it was, and I have this really, really bad unit of miles squared inches. And that really doesn't mean a whole lot to me, but what I'm going to do next is I'm going to convert. I'm going to convert to feet cubed. Now, a lot of times I just like to do all my conversions at once, but I don't have enough room to do it across the entire screen, and so I'm going to do it in chunks. I'm going to do into feet cubed first. And so I'm going to write down 126.5058 miles squared inches. I've always put it over 1. This is how I like to do my conversions. And what I'm going to do is I'm going to start using my conversion chart, which is up here. And I'm going to start doing things to plug in, or to cancel out things. Let's say that I want to cancel out miles first. I'm going to use my conversion for miles. I'm going to put my miles on the bottom so that it cancels out with the miles on the top. And this mile cancels out with only one of the miles up here. I have miles squared. So after that happens, I am left with just mile. So now if I look at the units that are left, I have a mile, I have an inch, and I have a foot. I still have 3 dimensions of length here. It's still a volume, but instead of it being miles, miles, and inches, it's miles, inches, and feet. So I've converted one thing into feet cubed so far. I want to cancel out the other mile, so I'm going to do this again. And when I do this, this mile cancels out with the mile that's left. Again, I still have a volume here. I have inches, feet, and feet. And I'm going to do this one more time. This time I'm going to cancel out my inches, which is going to be 1 foot over 12 inches. And the inches cancel out with the other inches, and I'm left with feet, feet, and feet. And when I multiply feet times feet times feet, I get feet cubed. So what I have now, when I go ahead and multiply this across, is I get a really, 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 really large number. And I don't have enough room to write it necessarily here, so I'm going to write it underneath. I get 3, 5, 2, 6, 7, 7, 9, 2, 9, 4.72. On the top, I have feet cubed all over 12. I don't have any units on the bottom. It's just over 12. And again, I like to show all of my steps. I just multiplied my top. I multiplied my bottom. That means I still have a fraction. I'm now going to simplify this. I'll go ahead and move this over so that I can put the answer next to it. This equals, after I simplify it, 29,38,98,274,56 feet cubed. Now, you might be saying, how come you're keeping so many of these significant figures? How come you haven't rounded? How come you haven't used your significant figure rules yet? And the reason for that is I like to do it at the very end. If I start rounding now, if I start multiplying it by some more stuff or adding things to it, then I'm multiplying a rounded number with another rounded number, and it gets less and less precise each time. So I've changed it into feet cubed. I'm going to go ahead and now convert to gallons. So to do this, I'm going to start with my original number, written as a fraction. Hopefully I'm copying this down correctly. And I want to cancel out feet cubed, and I had, right here, I have a conversion for that, feet cubed into liters, so I can convert this into liters. And I want to cancel out feet cubed, which is on the top, so I'm going to go ahead and put my feet cubed on the bottom, which is 0.0353 cubic feet, and on the top it's 1 liter. That cancels out my cubic feet, and my cubic feet, I don't have to do this multiple times because cubic feet cancels out exactly with cubic feet. I'm going to do one more conversion. I want to cancel out liters, so I'm going to put liters on the bottom. And I'm going to use my conversion that goes from liters to gallons, which is 0.264 gallons. Now, when I go ahead and I do this, I'm going to get a really large number again. I'm going to get 197,992,761.58187. And this is gallons. Now, this looks to be a very, very precise number. Now, if we think about it, chances are this isn't the exact number of gallons that actually fell. And so we want to use our significant figures here. And what I'm going to do is I'm going to look at our original problem. Our original problem had 4 significant figures when we were looking at how many inches fell. And we had 3 when we were looking at how many square miles there were. And all of our conversions were either exact definitions or 3 significant figures as well. So my answer should be 3 significant figures. If I were to do that, that would be 2. And because I'd have 3 significant figures, I would only keep my first 3 numbers here, which means I'd have to round this 9 up because this 7 would force me to. 9 rounds up to 0, which would push this 1 up to 2. And so these would be my significant figures. And then I would write 1, 2, 3, 4, 5, 6, 7 zeros after this. And if I wanted to, I could also write this in scientific notation. Which is also 2.2. Oops. This is also 2.20 gigagallons. And so this is one way to solve a problem. This is a simpler problem. It's not super complex. You might not have known exactly where to start or how to do it, but you can see that as we drew a picture, we talked about what we needed to do. We talked about some assumptions we made. We wrote out everything that we know from our variables to the equations and our conversion factors. And then I went through and I just went step by step and went and followed the process, and I ended up getting an answer. I should probably box or highlight this answer. I'm going to go ahead and highlight just because I have the capability to do that. And my answer is at the end written pretty neat. Now, again, if I wanted to make this really, really nice and I was submitting this for a homework or a project or a take-home test or something like that, I would want you to write it up really, really nice one more time, make sure everything was organized, everything's in its place, very easy to read, very easy to follow. You can see that I did add some words through here. Find the total volume, convert to feet cubed, convert to gallons. Maybe I could even write a little sentence above this saying the total rainfall in Forks for the month of January 2020 was, and really make it seem really, really in-depth, answering the problem completely.